In chemistry, we do lots of chemical problem solving. We use equations and we use something called dimensional analysis. Dimensional analysis is a way that we use units in order to help us decide what mathematical operations we are going to do to solve our problem. So units are extremely important. We want to make sure we write them with every number that we write. And we want to include them even in our calculations because this helps us decide if we've done our calculations properly. It also helps us decide if the number makes sense as an answer. So we do have to know how the units change when we do our calculations. So if we multiply two units together, then that unit becomes squared. Or if we multiply three of the same unit together, it would become cubed. If we add them or subtract them, the unit doesn't change. So in this case, we have centimeters. So if we add centimeters to centimeters, we get centimeters back. If we divide the same unit by itself, the units cancel out and we no longer have those units. So if we take centimeters and divide by centimeters, we get 1 or we get no unit. So using those criteria, they can help us in problem solving, and that problem solving method is called dimensional analysis. It sounds complicated, but really it's just using the units to help us do the math. So we want to set up and think about how we're going to proceed in our conversions or in the way that we change the units. So we want to make sure that we find a relationship. If we're going to convert inches to centimeters, we have a relationship that says 1 inch is exactly equal to 2.54 centimeters. Now 1 inch was changed so that this is an exact conversion. And so after the 4, there's an unlimited number of zeros. We're going to write a conceptual plan. We're going to start with our inches, and using that relationship, we're going to convert to centimeters. And that equivalency becomes a conversion factor. So because we want to cancel the inches, the inch part goes on the bottom of our relationship, and the centimeters are on top because that's what we want to end our problem with. That's what we want, the units we want our answer to have. So you may want to use a systematic approach to problem solving. The steps that are laid out by the book start by sorting the information, figuring out what you're given and what you're trying to find. Design a strategy. So what are the steps you're going to take in order to figure out the answer? You apply the steps to solve the problem, and then most importantly, check the answer to make sure that it makes sense. A lot of times it's pretty easy to forget the check the answer part, but this is the part that helps you decide whether or not you've reasonably done the problem and that the answer that you've gotten is correct. So let's try an example. We're going to start by sorting our information. We're given 1.76 yards. We're going to find centimeters. So if we make a conceptual plan, there's several ways you can do this and you'll end up with the same answer either way. We can start with yards and go to feet. From feet, we can go to inches. From inches, we can go to centimeters. So how many yards or how many feet are in a yard? Well, 1 yard equals 3 feet. And how many inches are in a foot? 1 foot was 12 inches. And we already saw our conversion that 1 inch is 2.54 centimeters. So those are our relationships that we're going to use. So now we can put this into our dimensional analysis. So we start with 1.76 yards. We're going to convert those relationships into conversion factors. We want our units to cancel. So we want the yards to cancel. So we're going to put the yards on the bottom. 3 feet goes on top. The number stays with the unit. Now, if we stopped our problem at this point, we'd have our answer in feet, but we can keep going because we're trying to find centimeters. So we know that 1 foot is 12 inches. And so the feet will cancel because we have one on top and one on the bottom. So that would be the same unit divided by itself. So they will cancel out. And if we did the problem here, our answer would be in inches. But we want it in centimeters. So we're going to put 1 inch on the bottom, 2.54 centimeters on top. Our inches cancel. And now our answer will be in centimeters. Now to do the math for this, anything that is along the top of our problem, we multiply together. If we have any units or any numbers on the bottom, we divide by that. Of course, if we divide by 1, we get the same number back. So our answer to this problem would be 163.6197 centimeters. Well, now we have to round. We need to remember our significant figures. So our relationships, our conversion factors are exact conversions. So that does not determine our significant figures. Our determining factor in this case is the number that we started with. So we have 3 significant figures in our 1.76 yards. So we need 3 significant figures in our answer. And then we want to check. So a yard is approximately, not exactly, but approximately a meter. So if we had 1.76 yards, we'd have about 1.64 meters. If we convert that to centimeters, this does make sense. The units are correct. The number makes sense. So we've done a good job with this problem. So here is one for you to practice using conversion factors. Pause the video, see if you can set up the dimensional analysis to come up with the answer for 30 milliliters into quarts. Okay, so what we're given is 30 milliliters. We're trying to find quarts. We're given our relationships. 1 milliliter is a thousandth of a liter, and 1 liter is 1.057 quarts. So that means that our conceptual plan, we want to go from milliliters to liters to quarts. So let's set that up. We want the milliliters to cancel. So we're going to put our 1 milliliter on the bottom, our 0.001 liters on top. Our milliliters will cancel. Now we want to find quarts, so we're going to put our 1 liter on the bottom so that it cancels the liters, and 1.57 quarts on top. And again, to do the math, you multiply across the top, you divide by anything that is on the bottom. So our answer would be 0.0317 quarts. Now we want to round. We started with 3 significant figures. Our answer has 3 significant figures. So our answer, we could leave this as 0.0317. Our units are correct. We were left with quarts as an answer. And milliliters are smaller than a liter, so we would expect to end up with something smaller than a quart. Now, the book lays out a very detailed way to do the problem. As you get more and more practice, you may not have to include all those steps in order to get the problem solved.